So our next speaker is Dr. Bill Lapenta. Bill is the director of the National Centers for Environmental Prediction. So for those of you who have never heard of that, it's a critical national center that is over a bunch of other centers, and I'll let Bill tell you all about that, and including the National Hurricane Center. So there's a lot of excitement going on there, and Bill's going to talk about the role of numerical models in building a weather-ready nation. But first of all, I wanted to show you a little video to tell you a little bit about NCEP and what they do. So let's take a look at that, and then we'll get on with Bill and his presentation.
The National Weather Service National Centers for Environmental Prediction, also known as NCEP, is your one-stop source for all things weather, water, and climate. Our products and services are essential to protecting our nation's property, lives, and economic well-being.
The NCEP vision is to be the trusted source of environmental predictions from the sun to the sea, especially when it matters.
NCEP is made up of 9 centers working together to deliver a precise, detailed picture of our environment from national and global perspectives. Weather products range from current conditions to a 10-day forecast. Seasonal climate predictions extend out to a year. These guidance products are used by local National Weather Service meteorologists to fine-tune forecasts for your area. All of this information helps communities prepare for and respond appropriately when severe weather strikes. This is the ultimate goal of the National Weather Service, to become a weather-ready nation.
All right. Good morning, everybody. My name is Bill Lapenta, and I am the director of the National Centers for Environmental Prediction, and I'm part of the National Weather Service. And I want to thank the organizers for inviting me to participate in this year's summit. The last time I was here was 2015. And I'm pleased to announce that today I'll be talking about some advances that we've made within NOAA to improve the operational numerical guidance suite, which really is a foundational part of the entire weather enterprise. So again, thanks Dave for the invitation, and I look forward to the presentation and an opportunity to answer some of the questions that you might have about the numerical weather prediction suite. So the things we're going to talk about today, I'll talk about a weather-ready nation being in the National Weather Service. This is an important part of what we do. And then I'm going to reflect a little bit on the 2017 hurricane season, not to a great extent, but in terms of some of the things that I've learned over that 3-month period. And then move on to talk about some of the advances that we're making in numerical guidance. And then I want to talk about a new and exciting project in terms of how we're trying to unify the forecast suite within NOAA. And then the last topic I'll talk about a little bit is the Weather Prediction Center excessive rainfall outlooks. So again, we'll have time to ask questions throughout this presentation as it's relatively informal. A weather-ready nation, I think we heard Mitch reference this earlier today. It really is about building a community that's resilient in the face of increasing vulnerabilities for weather, water, and climate extreme events. And this is more than just a slogan. It really is a strategic outcome. It's something that I think that the nation is really grasping onto. It's something that's resonating within the Department of Commerce. And it really is about, touching every county and every day and providing better forecasts and warnings, consistent products and services, actionable environmental intelligence. The most important part of this is connecting forecasts to actions. And we have more than 7,000 weather-ready nation ambassadors. These are not individuals, these are organizations and institutions that are working with the National Weather Service and the weather enterprise in order to build a stronger foundation for what we do. And the important point here is taking all the advances that we've made in technology. You've heard about GO 16, you heard about NOAA 20, all the great advancements in satellites, all the great advancements in physical understanding, the advancements in the modeling as well. But there's no intrinsic value of a forecast until somebody takes an action based on that forecast. And this is something that Louis Ugolini, the director of the Weather Service, constantly highlights when he goes out and speaks, is that a forecast really has no intrinsic value until somebody makes a decision on that forecast and takes appropriate action. And this really is what Weather Ready Nation is all about. The forecasts themselves, we've been spending more time as a National Weather Service translating, communicating the information to our stakeholders so that they can inform their stakeholders and their customers to take appropriate actions based on that information. And this is something that we've really been emphasizing. It's called going that last mile, right? A forecast by itself, we need to translate that information to our stakeholders so that they can use it and then advise their customers and clients to take appropriate actions. So this is really what Weather Ready Nation is all about. And so I'm going to reflect a little bit on a couple of the hurricanes this season. So as the director of NCEP, I am responsible for the National Hurricane Center. And this is my 5th year in the job. And the prior 4 years, the Atlantic hurricane seasons were relatively quiet, except for Matthew and a couple of others. So when Hurricane Harvey, or was just a tropical depression at that time, was going through the southern Caribbean and southern Gulf of Mexico, I decided my schedule was relatively clear. And I decided to fly from College Park, go down to Hurricane Center, just observe how we do operations at the Hurricane Center for Harvey. At that time, it was Wednesday morning, dropped everything, flew down, got there Wednesday night, and Harvey was a ragged tropical depression with 35-knot winds. Woke up on Thursday morning, got to the Hurricane Center at 6 a.m., and we know that Harvey at that time was rapidly intensifying into a Cat 1 storm, and then predicted to hit the Texas coast as a Cat 3. All that rapid intensification occurring within a short 6 to 9 hour window. And standing there on the operations floor, we were looking at GOES 16. And GOES 16 was not operational at the time, and yet, due to advanced preparation by NESDIS, National Weather Service, and the contractors, we were able to get those data down in real time. We were able to use those data. And standing on the operations floor of NHC, watching 30-second mesoscale imagery of GOES 16 and the rapid intensification of Hurricane Harvey really caught my attention. I had never seen anything like that in my professional career. And you had to step back and realize that what you were looking at was not a 6-hour loop. It was more like a 50-minute loop. Rapidly intensifying cyclone, the mass and the water that was being advected around in such a rapid form really caught me off guard. And I'll have to tell you that hurricane forecasters are kind of a staunch group. They don't like giving credit too quickly to new technologies. But I will tell you that GOES 16 is really changing the way they look at satellite data. We're seeing things in GOES 16, not just with hurricanes, but other phenomena that we've never seen before. So again, Mitch, I want to thank NESDIS for really getting that up there. We're going to learn a lot about phenomena that we're going to disprove theories, we're going to prove theories, we're going to prove new theories. So we're really excited about this application. But the thing about Harvey was that, you know, looking at the numerical guidance, for example, one of the things that we talk about all the time, we try to compare the European versus the GFS versus the Canadians versus the Japanese. And the danger of doing that is that you start to label things as one's better than another, and perhaps one gets more weight than the other. And we just have to be careful about this in the community, because when we use numerical guidance, it's important that you use the suite of numerical guidance systems available to you. And you look at the signals that those systems are providing to you. So with Hurricane Harvey, the composite track forecast for the GFS, the European, and the regional HWRF system were all pretty good. Okay. So they traversed it through the southern Caribbean, over the Yucatan, into the southwestern Gulf. And the big challenge we have is not so much track, but it's intensity forecast right now. None of the regional models or the global models were able to capture the rapid intensification of Harvey once it crossed the Yucatan Peninsula. So this is an area that we really need to work on. An extreme outcome of Harvey was the rainfall that occurred in Texas. And prior to landfall, 3 days out, we were predicting up to 30 inches of rain at that point in time. And we knew that the long range, the global models were predicting a stall of Harvey over Texas, which would lead to significant flooding. We had no idea how large it would be, but just predicting 30 inches of rain 4 or 5 days in advance was something that we're not used to. And then how do you convey that information to the public? That's a really tough challenge that we have. And then as Harvey made landfall, the precipitation estimates kept going up, eventually predicting up a storm total of 50 plus inches is something we've never done before. But the thing is, with the suite of numerical guidance and our physical understanding, we're able to gain confidence and slowly ramp up the precipitation forecasts for that particular event. And again, it goes to using the whole suite of numerical guidance systems and developing that coordinated and consistent messaging that we as a Weather Service provide out, and then you as the media, you have to take that, provide your own messaging, provide your own value to it, and then convey that to the public so that they take appropriate action. So again, being on the operations floor for Harvey, for just the genesis of Harvey, the rapid intensification, the landfall, and then being back at College Park for the Weather Prediction Center for the precip forecasts, really had a profound impact in my appreciation for what we do as a weather enterprise. Question?
Hi, I'm Frank Billingsley from KPRC in Houston. I'm a Harveyologist. The rapid intensification, the only thing I've heard about why that happened was perhaps an eddy from the loop current. Is that your take on that, or do you have another explanation?
So we don't know, but I'm sure there's going to be a lot of research done on that. One of the hypotheses that I've heard from the Hurricane Center is that, Harvey was pretty strong early on in its life cycle, and so there was a lot of circulation within the mid and upper atmosphere. That once it got over perhaps the warmer southern Gulf of Mexico waters, all that came together to cause rapid intensification. But to say that was just one thing, the warm sea surface temperatures, but I think it also had to have that environmental circulation to get it going again as well. But I'm sure we're going to see a lot of research done on that to better understand what caused that rapid intensification. It's a good question. So not too long after Harvey, we had Hurricane Irma. And Irma was a long-lived hurricane. It was a Cat 5 for more than 3 days. And this is a GO 16 loop from September 2nd through the 11th of 2017. And again, this was right on the heels of Harvey. And the thing about Irma that made it so challenging was, when is it going to make that right turn, right? It had a pretty strong trajectory. All the global models had it predicted, moving west-northwest. And then the big question was, what happens once it gets near the southern tip of Florida? Is it going to go up the east coast, affect Miami, or is it going to stay on the west coast? We just didn't know. And the thing is, when you look at the ensembles from the GEFS or the European or the Canadian, early on in the history of Irma, all of those ensemble systems were bringing up the east coast. And then slowly over time, we look at trends. All the ensembles were slowly drifting towards the west and put the peninsula of Florida, which is only 150 miles wide, into that path. So that's when we started to gain confidence that this was going to be a Florida event as opposed to an East Coast event. And the thing that's unprecedented about this is that, we saw that right turn was being predicted by all the guidance. Very few systems, if any, had it going into the Gulf of Mexico, continue on towards Texas, which would have been another natural disaster. But when would that system make the turn to the north? And because of the certainty or the confidence that we gained over time because of the guidance, the ensembles, the governor of Florida issued a state of emergency declaration on the Monday before that Saturday landfall. And again, that goes to the confidence that the weather enterprise provided to the governor to make that call, right? Of course, the details was, when would it make that right turn? And eventually, initial conditions, or I say early on, we thought that it would go up the east coast of Florida, and that was all the numerical guidance, by the way. It wasn't just one set of forecasts. The European Center had it going up the east coast, the GFS had it going up the east coast, and it was kind of a situation where first they were drifting to the east, then they drifted back to the west. And of course, you had to make a determination when it was going to make that turn. But In the end, it did turn, and it went up the southwest coast of Florida, inland for Tampa, sparing it from strong storm surge. But again, that right turn did verify. And I have to be honest with you. I did wake up in the middle of the night during Irma, and I dreamed that it never made that right turn. And I don't want it to sound, I wanted it to hit Florida or anything like that, but the amount of pressure and the uncertainty that the models today have the fidelity to capture that kind of a detail with a pretty high level of confidence is absolutely amazing. And Mitch was talking about the models, 210-kilometer model that we were running just 20 years ago. We never could have done this. So it's absolutely amazing how far we've come from a technological standpoint in terms of the fidelity of these models, global models, to give us signals that we can rely on. But that was something I'll never forget. And just kind of looking back over the last 25 years, Hurricane Andrew in 1992. And the policy then at the Hurricane Center was that, they didn't even use global models. Low fidelity, there was no confidence, the resolution, the physics, there was nothing good about the global models at that point in time. However, for Andrew, it did have a single L in the analysis, okay? So it had a minimum. But what we learned after Andrew is that as the models got better, there was some fidelity in there, and that we started to look at signals and find signals from tropical cyclones that gave us confidence to use those in our forecasting. Katrina in 2005, we started to have the cone of uncertainty for the Hurricane Center. We were using the global model suite. We still had trouble with rapid intensification with Katrina, and we still have that problem today. But you look at where we are in 2017 with Irma, again, coming back to the fact that we were able to get that right turn in all of the suites and talk about that with a high degree of confidence truly is amazing in terms of technological advancements that we have. So now I'm going to switch gears and talk about numerical weather prediction. And you guys and gals in this room are all avid users of the technology. So I'm just going to keep it at a very high level and talk about some of the things that we have coming down the line. Numerical weather prediction, Mitch covered the observation aspect of it quite well. I'm not going to touch on that, but obviously it's an initial value problem. So you have garbage in, you have garbage out. So we rely heavily on the observing system. 85% of the data we use is remotely sensed from satellite. That's not to say that other 15% isn't critical. So don't think that Raywin SONs are insignificant. They're absolutely critical to what we do from an NWP perspective, but also in terms of anchoring the satellite data as well. And then in terms of the models themselves, you have to have good physics, good dynamic cores, and good data assimilation. And Mitch showed that graphic of how we improved over time with skill, and how in the early 2000s we had a rapid increase in closing the gap between the southern hemisphere and the northern hemisphere. A lot of that had to do with the launching of microwave data, but also how we assimilate those data. We learned how to assimilate radiances in the mid-2000s, which means we extracted a lot of value out of the satellite data to help improve the quality of our numerical guidance. So data assimilation is a really important part of what we do. And then the third leg of the stool is high-performance computing. You need supercomputing to do high-fidelity data assimilation, and then to run the models 24/7, and to get those data out to you as quickly as we possibly can. So it really is a three-legged stool. Now, one thing I want to talk about, and Dave, I know you wanted me to talk about the European versus the GFS, and a lot of people love to have me talk about those things. I just want to make a point, and this is something that happened real time during Irma. We tend to focus on the deterministic solutions, and we tend to kind of do a competition between the GFS and the Euro and the Canadian, and maybe the Japanese. And I'm afraid that could be a bit of a disservice to the community, because we might be taking your eye off the ball. And during Irma, this was an article posted on September 6th. I'm not going to say who posted or where it was posted, but it was brought to my attention. And this shows like a 3 or 4 day ECMWF forecast. The title is "The World's Best Weather Prediction Model says there's going to be a hurricane hitting Miami in several days. Okay, and we all know that didn't happen, but it's still out there. And then 3 days later, 2 days later, this is while the event's going on, the same person published another article saying, U.S. models have been pretty terrible during Hurricane Irma. All right. So it's highly critical. I'm not taking this personally, but I think this is a big distraction. And some of the things that he had in that article were just flat out incorrect. And so I had to spend my time, and others had to spend time debunking this and providing corrections to the article, which were never published. But still, it's something that we just need to take situational awareness of, that we could be doing some disservice when we focus on deterministic solutions. And again, you know, you as a community, yes, question.
Welcome to our world.
Yeah.
This is Jim Gandy in Columbia, South Carolina. We're always getting these things. I bet there's not a person here that doesn't get a tweet from somebody saying, this is what's going to happen. And, you know, we're looking at all the models, and, you know, it just doesn't work out that way.
Yeah. But it's a communication thing. And we just have to work together to try to maximize the value of the ensemble-based systems. Yes.
Jennifer Okavina from Paducah. Even this morning, you know, we had an overachiever snow event in the last 24 hours. And I had comments in my feed from viewers that said, you guys should have gone with the European.
Well.
Because, no kidding, because it's come to a point where news directors now and our general managers like, I want you to show the different scenarios. And so now you've started training the viewers to follow the trends themselves.
Yeah.
And so it's like, you guys would have gotten it better if you know, followed the European. It's like, well, it doesn't always work that way, but
again, that's after the fact.
That's a no-win scenario, because no matter what model you use, if the next model is better, you should have used that model.
It's a tough business we're in, and I'm not complaining. This is just reality, and this is something we as a community got to really work on, because you have a lot of tools available to you, right? And of course, after the fact, people are going to pick the one, and well, this time it was a Euro, and next time it'll be the GFS, and the NAM or the HER or something. But you know, we just got to continually work on this problem of dealing with ensembles and uncertainty. It's not easy. It's going to get harder, by the way. Yes.
Yeah, Bill. Not too long ago, we had. I am Joe Murgo from WTAJ in Altoona, Pennsylvania. Not too long ago, we had, if you took a deterministic model and it showed 20 to 30 inches of snow in the western part of my viewing area and up to a foot in the central. Meanwhile, if you used, and even if you took ensembles, there were a lot in there. But if some other smaller range models were hinting at, and actually human knowledge knew this is not going to happen. It doesn't happen. We don't have rain to snow events like this. Are we going to get better at this? Because even the GFS had it, and I'm like, hey, don't believe the models. This doesn't usually happen. But I'll give it kudos. The RPM model showed less than an inch in the central part of our viewing area, up to 6 to the west. That's what happened.
Did you use the high resolution rapid refresh? I mean, was that showing a similar
the RPM? Yes, it was, but you're talking about it. You know, that's too late.
That's an interesting problem. The lead time is a problem. What about the NAM in that case?
The NAM actually did much better.
What about the SREF?
Again, the SREF was it was showing a fair amount because it's getting skewed by some of these runs that had just phenomenal amounts.
Yeah.
And, you know, those are interesting problems that we have. Are we going to, you know, how do we get past that?
Well, I think that precip type is a big challenge for the guidance, right? Because that's all about the model physics. And then lead time in terms of what system you're using for lead time information. So I do believe the models are going to get better and better and better. And that's the challenge right now is really in the mesoscale. And that's the HER problem, and that's, you know, that's out to, the HER is going to be expanded to 36 hours soon, so that's going to be helpful. But I think the big challenge for us in NWP is really moving towards the mesoscale, 3-kilometer type stuff, where the high impacts really are, especially for those kind of mesoscale phenomena. So, yes.
And I think for broadcast meteorologists, it's about, you're always going to have the trolls. I mean, I expect that on Facebook, but it's about the messaging. Look, winter weather is going to change day to day until we get 24 hours out, and then we get the best look at it. And it's just all about the messaging for on our side at least.
Yep, and that's a big challenge for all of us. And these are great questions because I'm going to kind of lead it. It's leading into some of my discussions further on down. So that's all I have to say about European and the GFS. I will say one more thing. So last week at AMS, the Director General of the European Center was there. It's the first time she was there, Florence Rabier, and I've worked with her for 10 years. And ECMWF had a booth, and the first time they did it. And on Wednesday, I was talking with Florence, and I was like, "Are you going to come back to AMS? You're going to have a booth next year?" And she's like, "Well, we got to see. We're not sure." And then she made a comment to me. She was taken back by the fact that so many people would come up to that booth and say, "You're sticking it to the Americans. You're the best model there is." And she was actually taken back by that because, we don't have a real competition with our other Met centers. We're few and far between, so we tend to collaborate and work very closely. And she is really moving within ECMWF to focus on the ensembles as opposed to the high-res deterministic. So it's just an interesting response that she had in terms of the feedback she was getting in AMS and this competition that was really being emphasized. And I'm just going to leave it at that. But we do collaborate very carefully with ECMWF. We have a scientific exchange program where we send somebody over there. They're going to send somebody over with us because there aren't a lot of groups that do operational numerical weather prediction. Dave?
Bill, I just had a quick comment, and maybe those of you in the room might be able to comment as well. But when you get to and I'm not working in television anymore, but when you get to the news management, they always seem to like conflict. They seem to like, putting one thing over, against the other, and not necessarily at the recommendation of those folks that are here in the room, the broadcast meteorologists. And I don't know, were you planning on making any comment about what Ed Rappaport said? Because I was like, during the hurricane, I think it was Irma, that was coming up towards Florida.
I don't know what Ed said.
I felt like calling Ed and giving him a high five over the phone because he was on with CNN. Okay. And somebody asked him during a live interview, "What do you think about the European model? Are you going to choose one over the other?" And I could see him boiling, right? And so that he had the perfect response, and that was, you should really pay attention to the official forecast. And, it was like, I almost hit the TV like high five because even the news anchors, they want to say, well, what do you think, this one or that one? And, it comes, the Weather Channel a lot, Euro versus GFS, things like that. I think it kind of feeds into that. And you're right, it should be more of a partnership. But I just wanted to, bring that observation out.
And that's a great point. And I'm a modeler technically, right? I worked on mesoscale modeling when I was doing technical stuff years ago. And when I go places, people want me to talk about the modeling, but the models are just tools. That's all they are. And the tools by themselves, you have to be really careful how they're being interpreted, because you could have novices interpreting the tools incorrectly. And so it's that intellectual value that we have and the interpretation, the analysis that we make, I think the human element aspect of it that puts these tools or the output of these tools in the proper context. And that's not easy to do. So I just want to really emphasize the intellectual capacity point, not just from the National Weather Service, but really the entire weather enterprise, is to take these tools with the known limitations and to really extract the maximum value from them so that people take the appropriate actions. That's not easy to do, especially when there's so much stuff out there. You got to filter it and decide what it is you trust and rely on and use that in your processes.
Bill?
Yes.
Just a quick comment from an online viewer. We have a lot of them now. This particular one was Joe Whitty. Hello, Joe. So Joe says, when we get a model that is right all the time, we will be out of a job. He says, IBM Big Blue will provide all viewers need to know with an app. So, you know, that seems to be the goal, right? And I think he's being pretty facetious. But,
I don't think it is the goal. I think what we're going to make our money is these high-impact events. And that's where you have a lot of uncertainty, and the devil's in the details. And I still believe that's where the intellectual capacity, the experience that we have as meteorologists, physical scientists, and communicators is going to be the most value, right? You can automate the process to a certain extent, but you're always looking for those areas where you need that human intervention to jump in and help interpret what's going on. That could be a rapidly evolving situation, but you know, I think that addresses what Joe is trying to say. Okay. Moving on, this is kind of what I've stressed already in the sense that, you know, the models are just tools. And I don't mean that flippantly because I'm a modeler. But I've seen some instances like the National Water Model. There's so much emphasis. It's a new hydrologic model that we're running in the Weather Service. And that's a great advancement over what we've been able to do so far. But I just caution the developers and those that use it to not emphasize so much that it's the model and the model is the forecast, because it's really just a tool that people use to make forecasts from that influence decisions. Again, they're tools, but they are foundational and they're key to what we do as a weather enterprise, right? Prediction is what we do. Prediction's in NOAA's mission statement. So we're always going to have to rely on models to a certain extent. There's no getting around it when you talk about prediction. Looking at the operational production suite, and I know this is a complicated diagram because it's a complicated production suite, but it's very broad in scope. It goes all the way from on-demand dispersion modeling. I heard high split mentioned a little while ago. If there's an accident somewhere or a chemical spill, the Weather Forecast Office can have a dispersion model activated to determine where that plume might go. We have a number of regional systems. I'm sure you're familiar with some of these, the Rapid Refresh, the HER, the NAM, the high-res windows. These are regional CONUS applications. Then you move upscale, and you have the short-range ensemble forecast system. You have the global forecast system. And the systems in blue are ensemble-based. And NCEP in the early 2000s really did lead the way operationally in terms of getting ensembles implemented operationally. And it was not too long ago I was talking to somebody about the 2000 snowstorm that hit DC. It was a surprise event, right? The No Surprise Snowstorm, I think it was called. And that, because of that event, it really forced NCEP to get ensembles implemented sooner rather than later. So it's really important here that we just talk about just the mere fact that we do have a large number of ensemble-based systems that we're running operationally. And I'm not going to talk about all these systems today. I'm going to really, what? 30,000. 30,000. Okay, no pressure, no pressure. I'm just going to talk about some of the downscale systems. Some of the things that we talk, mesoscale, right? The high-resolution rapid refresh. We'll talk a little bit about the NAM. And then talk about how we're trying to unify this forecast system because it's grown over time and it's no longer manageable from an individual system perspective. So I want to talk a little bit about the bombogenesis event we had a couple of weeks ago off the East Coast. And it was interesting because as that was going on, or the precursor to it, a lot of folks in the social media and on academic distribution lists, we're talking about similarities of this event to the 2000 No Surprise Snowstorm. And it was just interesting to watch this unfold. But I want to talk about this event in terms of the numerical guidance systems and how those guidance systems were applied to it. So this is from the Weather Prediction Center. This just shows the cyclone when it's pretty well wrapped up and the satellite signatures. And again, watching this on GOES 16 was absolutely amazing, Mitch. I'm addicted to it. I'm a believer. I'm all in. I just, once you start looking at that 30-second imagery, you can't take your eyes off it. It's really cool. So just looking at the sequence of events in terms of the numerical guidance being able to grab onto that signal. And so what you see here on the far left is the 12Z analysis on January 4th from WPC. There's that intense cyclone off the East Coast. And you can see that even at day 7, there was some signal in the long-range guidance. Again, this is a WPC product, but it's based on numerical guidance. And it's not just GFS, but it's the ensemble of numerical guidance available to them. Sure, we didn't know how strong it was going to be, but we thought there was a signal. Something would be off the East Coast. Day 6, signal still there. A little more confidence. Day 5, signal still there, and we're starting to see that it looks like it might be a little more intense than we thought originally. Gaining confidence. Day 4, signal still there. Day 3, signal still there, and now we're starting to get into the time frame where some of the regional models come into play. You got the NAM, for example. It's just not global anymore. You got the NAM, still out of range of the HER, but the NAM and the SHREF are there. And then as you get closer, day 2, and then day 1, and then you've got the verification. And this was a challenge because we weren't sure, first of all, how intense it was going to be. And we really didn't believe the intensification rates that some of the models were giving us, even the global models. Were 50 millibars in 24 hours or something like that. It was really off the charts. But also what's more important really is the impacts, the sensible weather elements. Snowfall, right, along the Georgia, South Carolina coast, North Carolina, what was going to happen in New York City, what was going to happen in Philly and DC, and then, of course, what was going to happen in Boston. So, that's where we're really focusing on the impacts from the sensible weather elements. And so, I just kind of quickly grabbed some graphics, and I think you applied the systems in the same way. But in order to get confidence in a medium range forecast, you look at the ensembles, and this is just 500 millibar. And we saw that the ensemble-based systems had a trough over the eastern U.S., and it was a consistent signal. And this is an ensemble mean, so this is telling you with a pretty high level of confidence that, all right, you're going to have a pretty large-scale trough sitting on the East Coast in 7 to 10 days. Then as you get closer in and you start to look at the trends in the guidance, and this is, I'll give a shout out to Levi Cowan at Florida State University for Tropical Tidbits. I love this webpage. How many of you use it? Raise your hands. Oh yeah. Grad student, Levi's a great guy. It's a very flexible tool that allows you to do a lot of things with the model guidance. You can animate it. And what I like really is that you can compare trends in a particular guidance system or even between guidance systems. And so here's just an example of, this is something I was doing during the event, was just to see how much variability there was run to run in the HER, right? The HER's launched every hour, runs out to 18 hours. And things of interest for me was, well, where's the low, the intensity of the low, and really the precipitation, rain snow boundaries, that's an important part of it, and also the western edge of the precipitation. So again, this is just an example of, it's one system, it's not ensemble based, but using it to infer trends and how those trends are threats increasing over time of snow in New York City, or is it decreasing? And again, this is how, using the ensemble system or using the guidance system to your advantage. Trends are really important. And I just threw this in last night because I thought it was important as well. And what you see here on the left side is a product that's created by the Weather Prediction Center. And again, you're seeing low pressure centers based on the short range ensemble forecast system. Excuse me. And again, this was for the East Coast event. And you could see that there was quite a bit of spread in the position of the low centers, even just 3 days in advance. But again, it's an ensemble-based system, and as time goes on, as those clusters perhaps get smaller and smaller, or the spread decreases, you get more and more confidence. And how many of you have seen ensemble plume products? Okay, great. These are really exciting products that are available from the GEFS, available from the SHREF. They're available from the high-res ensemble forecast system we're going to talk about shortly. But the SPC webpage has them. The WPC web page has them. But again, it shows you the possibilities. It shows you the members of an ensemble-based system, what the possibilities, the range might be for a particular location. So do a lot of you use this in your forecast production? It's a tool. So, but you find these useful? Good, I'm glad. I find them useful as well. Okay, so
Bill, real quick, was
yes.
that link that you had there? The one thing I found, and I don't know if other people have found, a lot of the main site I use for the plumes has gone to a map where you select. You can't just go straight to a site. Is there a site you would say I can call up to plumes for KAOO, for example, straight direct?
right from the model, right from the grids?
Well, yeah, yes. Where instead of going through their interface, where I have to go zoom around and find.
I don't know. We could talk afterwards.
Okay.
Show me what you're doing, and maybe I could find something for you.
Okay. Oh, that'd be great.
Yeah. I'm here to help. You know that.
All right.
But it's great that you have access to these tools and you know where they are, because it's only going to get, I think, better with time as we get to the higher and higher resolution ensembles. Okay, so now I'm going to just talk about some of the upgrades that we've done recently and that we're going to do in the near future. The NAM has always kind of historically had a bad rap, and perhaps justifiably. But I would argue that over the last several years, the upgrades that they've made to this system, in part because of the feedback from the community, and we get a lot of feedback, mind you. Some in the modeling center will call them complaints, but I call it feedback. And we value the feedback that we get from the community. Because I think in the end, it's really helped us make improvements to the NAM system that's made it, I think, a more viable, even though it's a deterministic system, it's more viable than it was in the past. And this is just an example of an event in 2015, a retrospective event that we used. We made significant improvements in the data assimilation system, right, the initial value problem. And we use radar reflectivity in the data assimilation system as well. And they also made a large number of improvements in the model physics, because that's where you really get the biggest bang for the buck. And so I think the last upgrade, was last year, and we are no longer doing upgrades of the NAM. The NAM is frozen. And I'm going to talk more about why that's the case shortly. The SREF is frozen. We're not making any more upgrades to the SREF. All right. And part of that reason is because we're moving to a unified forecast system, and so we're moving our development expertise towards the development of that system and not developing these any longer. So again, I just want to give a shout out to the NAM. Don't discount it right away. I know that it does have a high bias occasionally in precipitation areas, snowfall, but I do believe it's gotten better over time. So just look at it critically and carefully. And just don't immediately discount it. It's going to have to earn your trust, obviously. But I think with some of the recent East Coast event snowstorms, even dating back to last year, I do believe that it provided some value. And this is just another shout out to the Storm Prediction Center and their webpage in terms of being able to extract information from these high-res deterministic and ensemble-based systems. Again, this is just an example of the plume, but they have diagnostics that are calculated from the HER, for example, the high-res ensemble forecast system V2, the SREF, and the SREF plumes. And what's nice about this tool is that these are algorithms that are processing or doing post-processing on a large amount of ensemble data and breaking it down into not just your general weather parameters, but more specific to hazards, whether it be severe weather, there's fire weather as well, there's winter weather. So these are really being designed specifically for different service area applications. And if you're not familiar with this website, I encourage you to take a look at it, and you may find some useful information for your applications there. How many of you use the HER? How many of you like the HER? Yeah, okay. So the HER is the High Resolution Rapid Refresh. It's a 3-kilometer continental-based forecast system. It runs every hour out to 18 hours. And I'll have to admit, I think we implemented this maybe 2.5 years ago. I can't remember now. But a lot of computer time goes to this system. And it was really designed for aviation purposes. And, you know, about 4 years ago, I was questioning the requirement to run this every hour. I go, who needs this thing every hour? What's the value going to be? So I was a skeptic. And I pushed back, and Stan Benjamin, the lead developer at GSD, would say, no, we need it. And even Louis kind of pushed back. But I'll have to admit, once we implemented this, and the improvements that have been made in the physics for the HER, and that fact that you have it available to you every hour, in terms of when you have an event that is rapidly changing, like a rain snow event, or a severe weather event, having a refresh of your guidance every hour is not as much overkill as I thought it was going to be. In fact, again, you look for consistency, you look for trends. And I think, if anything, that hour frequency allows you to gain, or maybe not gain, confidence in the quality of that guidance for you to help make decisions. Does that make sense to everybody? Do you think that's true? Does that hourly update benefit you in what you do in your jobs?
Hey, Bill. Howard Bernstein, WSA. When it's consistent, yes, because sometimes you see in the as I like to call it, go 180, hour A, hour B, hour C, flipping and flopping. But when it's consistent, yes.
Okay, but does that, when it is inconsistent, does it raise questions in your mind, or do you just discount
I
it?
kind of discount it because I think it doesn't have a handle on what's going on, and I try to look for something that's giving me more confidence.
Okay. So when that happens, I encourage you to document it and send a note to Curtis Alexander or Stan Benjamin at GSD, because that kind of insight and observations is invaluable, because what they'll do is they'll go back and look at it. And during the next development cycle, try to work on that particular event, especially if it's something that is happening systematically. Because you may be seeing something that the developers aren't. So that's a really important part of the feedback process.
Doug Kammerer from WRC in Washington. I use it just about every time we have severe weather coming through. I think it's a fantastic tool. I wish we would have had it in 2012 when we had the derecho event coming through. That would have been a phenomenal tool for us to track that. I mean, right now we have models that are coming out every 3 hours, but even those, if a model comes out every 3 hours and that one's a run that you think, nah, I'm not going to watch that one, you're waiting another 3 hours. Even if you have a run of the HER that is not something that you thought you were going to see, and it doesn't continue with the previous thought process, you can put that away and say, okay, let's see what the next hour goes, because it is going to update that much faster than every other model. So it is a huge tool for us, and a huge way for us to get out severe weather threats to the public. So yes, love it.
Yes.
Yeah, I would agree to you. Brad Panovich from WCNC in Charlotte. For timing in particular, the HER is really amazing, because you get that hourly update. The start and stop time of precipitation or events is really key in there. I think it runs a little hot as far as reflectivity and preset, but for timing, it's really, really useful.
And so I do encourage you, anytime you have an observation about a feature in this system, Curtis Alexander, do you know Curtis Alexander? All right. Afterwards, I'll give you his email address. No, I'm serious. This is no, because I'll give GSD, Curtis and Stan Benjamin, a lot of credit as developers for this system, because they reach out to the community, especially the Weather Service field folks, and work with them hand in hand to determine what's important to them. And the feedback that they get has really led to what I'll call rapid improvements in the quality of the guidance. So the point I'm trying to make here is that they will listen to you. It's not a complaint, it's an observation. They will listen to you, they will work with you to try to improve upon the quality of the guidance that they're providing. And the modeling center is doing that now at NSEP a lot more than they used to as well. So your eyes are really important in terms of helping us do our job better, so you can do your job better. So in terms of upgrades, the next HER upgrade is planned for May, right around, we'd like to get in earlier, but I think it's going to be May. And the key thing here in terms of not just physics upgrades, but we're going to extend the 0, 6, 12, and 18 cycles to 36 hours. So you can have a high-res HER run to 36 hours 4 times a day. And again, I thought that was crazy a few years ago. But again, based on how the field uses this tool, I'm convinced it's worth the effort. And it's worth the investment in high-performance computing as well. So that'll be coming soon in May, early May, hopefully, of 2018. And we heard a little while ago, Mitch talked about smoke. The HER folks have been developing inline smoke capabilities, which basically allows, you have to get initial condition from satellite to tell where the smoke is, the emissions, and then the model equations will transport that smoke in time. And that, I don't think that's going in operations in May, but they're running it experimentally at GSD in Boulder, Colorado, and they have that data available on their website. So they're very proactive in sharing information, even as the models are being developed. Again, I think this is a really important part of what we do as a business. And this is just an example of the HER during a high impact event. Severe weather, I think it's proving its value there. But I think we're also seeing it with some of the other applications, like you talk about winter weather, for example, and flooding events as well. So it's really just not about severe weather. I think it has applications across all the service areas. Talk about ensembling. We are working towards a convective allowing ensemble for the continental U.S. It may or may not be HER-based, but right now, GSD is working on a HER-E. The E is for ensemble-based systems. And this is something that's been under development for a couple of years. They're running it in real time. It's not an operationally hardened system, but again, it's being run in real time. And the big challenge here is how we use this data in our operations. How reliable is this convective allowing ensemble in terms of giving us probabilities for severe weather? And this is something that we've been working on. It's a big scientific question. Can you use a single dynamic core? Do you need multiple models to get a good convective allowing ensemble with a proper distribution and spread? But this is a big area of development, and I think this is going to change the way we do business probably in the next 3 to 5 to 10 years, because these types of convective allowing ensemble systems are going to be running operationally. And how you use these data in your applications is going to be really telling. There's going to be a lot of work that has to get done in post-processing, for example. Another tool that we have is called the High Resolution Ensemble Forecast System. And really, how many of you have heard about the storm scale ensemble of opportunity? Nobody's ever heard of it. Okay. So we've been running operationally what we call high-res windows, a number of different nests throughout the CONUS. And wherever they overlapped, the Storm Prediction Center would take those data and create a poor man's ensemble from those data. And it was called the Storm Scale Ensemble of Opportunity, or the SSEO. And it was designed, so what they did was they developed a lot of algorithms that would extract information about severe weather. And what they discovered over time is that kludged ensemble was providing some very valuable information about severe weather. All right, the mode of convection, is it going to be hail? Is it going to be tornadic? So there was some real useful information out of that kludged ensemble. And so what we did was we hardened that ensemble by adding another operational member, and so now it's called the HREF v2. But the point here is that the HREF v2 is now the benchmark by which we're going to measure the future of ensembles, convective allowing ensemble systems. And the big challenge here is, from a scientific perspective, can the scientific community create a well-behaving convective allowing ensemble that will allow us to get a better handle on predictability or confidence levels for severe weather prediction, for example, or winter weather prediction, or heavy rain conditions. And so the HREF is available. It can be viewed at SPC. They've got a viewer again where they extract information for different hazards. Now I'm going to shift gears again and talk about a little more about the high-res ensembling. So how many of you have heard about the Hazardous Weather Testbed in Norman, Oklahoma? How many of you have participated in it? Okay. So this is one of, I think there are at least a dozen NOAA testbeds right now. And every spring, I think for the last 15 years, NSSL, SPC, and Oklahoma University have been holding this testbed where they bring in researchers from around the country. They get high-resolution models running operationally, and they bring in, they sit the researchers next to forecasters in kind of a surge-type environment where they're focusing on evaluating experimental numerical guidance for severe weather applications. And so several years ago, I was out at the Hazardous Weather Testbed, and the last time I was there was like 2003. So 2003 and then 2015. And I was kind of taken back by the large number of ensembles that they were still testing. And I said, how are we ever going to, as a community, make some really hard decisions about the configuration of a convective allowing ensemble for operations if we just continue to do this kind of hodgepodge approach of looking at a plethora of ensemble systems? And so they actually listened to me. And what they did was they designed experiments where they could start to answer questions about the configuration of these high-res ensembles. Big scientific question: can we use a single dynamic core? Or do we need multiple dynamic cores? Can we develop an ensemble with we perturb the physics? How do you create a data simulation to get the proper spread? These are big scientific questions. And by the way, running these experiments is very costly. High-performance computing is expensive, and these are large domains, high resolution. So the thing I want to point out here is that the Hazardous Weather Testbed has been working really hard at addressing questions about convective allowing ensembles. And what they did was they formed what they call this CLUE project. How many of you have heard about this? CLUE. All right. You need to look it up and take a look. Because how many of you know Cliff Mass? All right. Cliff. He's a colleague. And he's outspoken. And he has been really passionate about the fact that we need a high-resolution convective allowing ensemble for the continental U.S. And this group, or this project, CLUE, Community Leverage Unified Ensemble System, is really designed at answering some of those scientific questions that will help us determine what we should do operationally in the next several years. And if you have a chance, just look this up, take a look at what they do. But I'm really excited by some of the work that they're doing. And it's not just one organization. It's NOAA, it's got the Environmental Modeling Center, it's got Weather Service, OAR, NSSL working together. It's got NCARS working with us and folks from the academic community. It really is a national collaboration where we're trying to address some of these questions about dynamic core and data simulation. So if you get a chance, take a look at this, just look it up. If you do get a chance to go out to the HWT for several days, I recommend you do it because it's really a worthwhile experience. Okay, shifting gears again, getting to the home stretch here. So in 2015, when I stood before some of you here, I was formulating a plan to get an external review committee developed for the NCEP production suite. That's a scary thing. Anytime you invite somebody into your house, you're never quite sure how it's going to work out. But I was at a point at the NCEP director realizing that our production suite was at a level of complexity that's no longer sustainable. And so I pulled a group of subject matter experts together. And you can see Cliff Mass is sitting there. Fred Carr, Ricky Root are the co-chairs. And Andy Brown of the UK Met Office served on this panel. And we brought everybody together, and they did a holistic review of the production suite in 2015, August to be exact. And some of the findings that they provided, got to reduce the complexity of the suite. unified collaborative strategy. We've got to build partnerships with the academic community, leverage their expertise. And it's not just the academic community, but it's the private sector as well. Enhance high-performing computing capabilities. We talked about that earlier. And again, involve the stakeholders in the development of your product, just like GSD does as well. So that was 2015. And I would argue that forming that committee, getting their expertise and their advice, has really set us down a path in NOAA that I believe we're going to be better for in the long run with regards to our complete corporate modeling suite. So not long after, we formed a committee or a team to look at the future dynamic core, or the engine, if you will, that we're going to run for the global forecast system. We've been running a spectrum model for the last 25 to 30 years. It's hydrostatic. It's got limited capabilities. So what we did was we worked on a project to identify what we should choose as a non-hydrostatic dynamic core. And so for a year and a half, we had NCEP working with GFDL, working with NCAR, working with GSD. There were 6 models being tested in a battery of systematic tests. And what we decided on was to use a dynamic core called the Finite Volume version 3. It's got a history at NASA. The lead developer is S.J. Lin at GFDL. We made that selection a year and a half ago. And that dynamic core is going to replace the spectral model in the global forecast system within 2 years. And we're already doing beta testing of that dynamic core in the GFS slot. And the main reason we're moving towards that system is it's going to give us a lot more flexibility moving forward than we would have with the spectral model. It would allow us to run it at convective allowing scales. We can run it for medium range weather prediction, and we can also run it for our seasonal applications. So this is the unified forecast system that we're building within NOAA in partnership with NCAR and the academic community. This is a big change. And this is why we froze the NAM and why we froze the shroud, right? This is a big risk we're taking here, but we believe scientifically we're on the right track. And so a little while ago, I showed you the production suite by system. That box that you see, or the boxes you see on the upper right left-hand corner, that's what it looks like, and all the connectivities between those boxes. So each one of those is almost its own individual system, its own individual dynamic core, its own physics set, its own data simulation. We can't do it anymore. So what we're trying to move towards a more unified approach, a single dynamic core, scale-aware physics, that, in other words, if you make an improvement to your hurricane prediction, hopefully that improvement is going to feed back into your winter weather, it'll feed back into your seasonal system, and if we do this right, we'll make this system available to the academic community, the private sector, so that they can work on it with us together, so we can take advantage of the intellectual capacity we have as a nation to improve the operational guidance. We've had a lot of things happening in the last several years, but this is probably one of the biggest things we're doing inside of NOAA from a modeling perspective. And think about the cultural change here, right? There's a lot of ownership with modeling, yet we've got GFDL working with EMC, working with GSD, working with AOML, working with NCAR, working with academia to try to improve the operational system here in the U.S. This is a big deal. And it's making pretty good progress. And so a little bit about the FE3 GFS. We're cycling it right now. It's hooked up to our data simulation system. And probably in about 3 or 4 months, we'll be running it operationally at NCEP in a beta mode. In other words, it's not replacing the GFS, but it'll be available in concert with it. And we plan on making these data available to the community. And this is something we would never do years ago, right? We always had this fear if we provide data too early, the community's going to get one bad forecast, they're going to throw up their arms and say we're not interested anymore. But we've discovered over time that giving these data out sooner rather than later, more eyes on, is going to help us find problems a lot sooner. And it will also help the community gain confidence in that tool as it gets developed. So you become part of the development process. So this is something that we're working on, and we hope to go operational with this system in FY19. And I do believe that it's going to be better than what we're running operationally today. And I just had to throw a couple of results slides in here. Again, I told you we're cycling the FE3 in our data assimilation system. We're constantly monitoring on a daily basis. We see some very positive signs that it's good as, if not better than the GFS already in some areas. We're looking at Atlantic tropical cyclone tracks. We're looking at intensity. We're looking at precipitation forecasts. These are all really important, sensible weather things that in the end will make our global system better. So every day that goes by, we're getting more and more confidence that we'll be able to make this switch. And anomaly correlation, Mitch referenced this a little while ago. The FE3 GFS base is outperforming the GFS right now in the Northern Hemisphere anomaly correlation. May not be a big thing to you, but it gives us confidence that we're heading in the right direction. And on top of it, we also have a team that's looking at the convective allowing scales of the FE3, which is giving us confidence that we will have a dynamic core that can be applied from convective allowing, medium range to seasonal. So eventually, the HER that we're running today may be FE3 based as opposed to ARW. It's going to take some time, but eventually we'll get to that point where we say we're going to freeze the HER and then move that to the FE3 dynamic core. We're not quite there yet, but might be in a year or two. And I don't think I'm going to talk about this. The only thing I'll say is that, we can't do it alone. And I give my colleagues in NOAA a lot of credit because we're changing a culture. I'm a collaborator by nature. I truly believe in working together and building partnerships. And I think this country is in a really good position to take our operational guidance to the next level. The Europeans, their business model is very focused, right? They invite people to come in and work on their system. Unfortunately, we in the U.S. really didn't have that opportunity. The GFS was kind of closed. It wasn't open to the community. It wasn't community-based. So we're changing our business model here in the U.S., and I truly believe that we're going to be better for it in the long run. The last thing I'm going to talk about, I just got a few more slides. Dave wanted me to talk a little bit about the WPCFA rainfall products. We just recently, I don't know, was it last year and a half to 2 years, created an excessive rainfall outlook. And again, the reason we could do this is because the quality of our numerical guidance is getting better with time. We're getting more confidence in it. How many of you are familiar with the ERO? How many of you use this in your operations? Okay. So right now, the way it's designed is that we issue it for day 1, day 2, and day 3. And the policy is that we cannot issue a high risk for heavy precip at day 3. However, we did waive that policy for Hurricane Harvey. And there may have been one other event we did that as well, because of the confidence that we had for flash flooding potential at day 3. How many of you find this product useful? Okay, this is good. I know you wanted Greg Carbon out here to talk about this, but he couldn't make it. But we could talk about this later if you need to as well. It was quite a year for WPC and really the Weather Service at large, a large number of flooding events. I talked about Harvey already, so I'm not going to go into it here. But, again, coming back to the entire Weather Service, it really is a collaborative forecast process. It's not a national center versus a region versus a WFO. We really are working together to develop a consistent set of messaging, exploiting the expertise that a national center has, exploiting the expertise that a WFO has or a river forecast center, working together to get that messaging out and to make sure that there are checks and balances on the forecast process. You'd be surprised what each group learns from each other by communicating and sharing intellectual capacity. And this is just, I think, one of my next to last slides. Again, we're setting first. We would not waive a policy if we didn't think it was prudent. But again, issuing high risk at day 3 is something that we had to do this year because it was prudent to do. And then the messaging that goes along with that. Words, as you know, have to be chosen very carefully. You know this is your job as communicators, and we're learning that as a National Weather Service, that words have a lot of meaning, and we just don't throw them out there lightly. Just in closing, our vision is really building a weather-ready nation, and it's not your parents' National Weather Service. We are working together in ways that we did not work together in the past. We're trying to be as foundational to the weather enterprise as possible. And that means working together across organizational boundaries in a selfless way, which is, again, a culture change. I'm a collaborator. I'm not going to stand here and pound the chest of NCEP. It's not my nature. It agitates me. But I do believe in intellectual value that we have as national centers working with weather forecast offices and regions. And again, it's going that last mile. It's about the trust that we develop with our stakeholders. It's that face-to-face. It's the inflection in a voice. That's what really matters. And you all know this, because it's part of your job as communicators. It really matters, that eyeball to eyeball, that inflection, the tone, the body language. That's the relationship aspect that you have with your communities, and that we are building as a National Weather Service with our communities. So that's all I have, and I think we still have some time.
Bill, thank you very much. It's terrific. I know we have a number of questions here. We also have a question or two online, so we'll get to that as well. So why don't we start, Jim? Go ahead.
All right, Jim Gandy, Columbia, South Carolina. These improvements in the excessive rain forecasts come at a really good time. In South Carolina, we've dealt with 2 major floods back to back, 2015, 2016. And in fact, in 2015, this is probably not the first time I encountered it, but when it's on your doorstep, you tend to take note. A lot of the guidance back then was forecasting just unbelievable amounts of rain, and we had never seen that before. In fact, the record for Columbia was just a little over 6 inches of rain, and in a 2-day total, the east side of town got 21 inches of rain. And then a year later, we're faced with the same sort of thing along the coast, not so much around Columbia, but along the coast. And again, the guidance is showing us something that we hadn't seen before. And so I wasn't surprised when I saw from some of the guidance that we were getting for Hurricane Harvey in the Houston area. My reaction to that was the same reaction I had back in 2015. Wow. If the guidance is if we only get half what the guidances tell us, it's still a record. And we're seeing these extreme rain events, and those are just a few, because we've seen others as well, Louisiana as well. We're just seeing some really extreme rain events, and this guidance is very important to what we do when we're trying to warn the public.
Yeah, I remember the 2015 event, right, with Joaquin off the coast and the influx.
Right.
I was relatively new to NCEP director at that point in time, but I remember speaking to the media 2 days in advance saying up to 20 inches. And to say those words and then watch myself say those words was just like, wow.
Well, we knew the event for Columbia was going to be a Saturday night to Sunday event. That was going to be the focus. And back on that Thursday, we said, this is an event of historic proportions. And we were cautioning. In fact, even from our own operation, there were football games scheduled that Saturday night, and particularly Clemson was playing. We did not send anyone to the Clemson game because we knew that they would be coming back right into a flood. We said we can't do that.
Yes.
Hey, Bill, Howard Bernstein, WSA Washington. You were talking about collaboration, and a couple times this year with WPC. Back in June, they had a stakeholder meeting, and more recently, as part of a little focus group, they were looking at their colors because some folks were concerned that some of the excessive rain outlet colors, I think, were similar to some of the QPF colors. So I know there's a lot of work going on, even on how they look, and even on many of the websites from the different agencies within NOAA have different looks and different feels, and I just get the feeling, first of all, let me just tell anybody in this room, if you get a chance to be part of one of these groups or one of these meetings, go. They actually are really interested in our input. I know it may sound bizarre, but they're taking an active role in collaborating with us, the end user, and asking what we want, what we think. What do we think of the map, even? The legends. Some people were complaining because all the legends are in one spot as opposed to having maybe labels with the contours on the map. So you got to go back and forth, and they were like, oh, that's great, thank you very much. So just to add to what you were saying about collaboration, and with inside and outside of NOAA, it's been nice to see.
So Dave Novak is a collaborator as well, right? And so I think WPC...
Yeah, well, Greg Carbon got me the invite. So.
And Greg. They become very aggressive in reaching out to the community, and they're making changes quickly. If you look at their website, they're taking your feedback almost immediately and incorporating changes into their graphics that we wouldn't have done so quickly in the past.
Like one of the questions was, the surface analysis comes up. They were thinking about maybe getting rid of that. And there were a lot of people like, no, we really like that. And that's been a legacy product and one of those things, a staple really for ever.
But we modernized it. We've added layers, so you can click layers now, and so it's getting more flexible, so you can tailor to your use. And the last, I will say, there's a question there, but we do rely on focus groups because getting the colors, with the storm surge watch and warning graphic that went live this year, we use focus groups and social science and to try to get that right.
And let me add one other thing while I'm here. It's been a pet peeve of mine. The simplification process, generally good, but I think losing freezing rain advisory to a winter weather advisory diminishes the threat there. And I think that was a little overdone, but overall, a good way to go.
Thanks, Howard.
Bill, we have a question online from, I don't think this is a weather intern, Bob Ryan. Everybody say hi, Bob.
Hi, Bob.
So Bob says, how do we as a community get away from this once in 100 year, once in 500 year rain or storm classification when these events are now coming once every few years, as in Houston in the last 5 years?
Yeah, that's a great question, Bob, and I don't know what the answer is because climatologically, we try to label those things and think that by doing so, we're providing some valuable information to the public, when in fact we may not be. So I think it's something we need to revisit and carefully think about. Because if we're seeing that it's really, in the end, confusing people and taking value away from our point, then we need to carefully reconsider it.
And we have another question online here from Joe Whitty. He says, if there's time at the end in your vast experience with the short-term models, do you see things that make you suspect that some climate change fingerprints are there?
I don't, I'm looking at these events, and the frequency of the events seems to be increasing, but our situational awareness of these events is also increasing. And I'm just speaking now from a weather service perspective, where the minute we have an event, we're constantly doing post-analysis. And I think that's one of the reasons why we're getting better, is because for these high-impact events, we're doing a timeline analysis. Did we miss anything? If so, how could we improve it? Even if we think we did well, how can we do better? So I think part of the answer is that we're just becoming much more situationally aware of these high-impact events and all the impacts that occur from them. So that's how I explain it.
Anyone else have any other questions?
Yeah, Bill, Steve Weigel from NBC in West Palm Beach. I'd be curious of your thoughts on hurricane intensity forecasts. What do you think the future holds? because we are kind of flatlining.
I think we're going to get better. The Hurricane Research Weather and Forecast System, the HWRF, it's at 2 kilometers now operationally, and it's not quite there yet. But we have made improvements in rapid intensification. It's not anywhere close to where it needs to be. But I would argue as those models perhaps get down to finer resolution, with the proper physics and a proper coupling with the ocean and waves, I think eventually we'll get there. I think we're going to have the technology. And again, what we're going to see from the GO satellite in terms of eye wall replacements and things like that. And by the way, the HWRF can do eye wall replacements, right? But maybe not at the right time. So I truly believe that our science technology and the research that we're going to do, we're going to get there. That's me speaking, not the Hurricane Center.
The track forecasts are just amazing, and the advances it's incredible. We dropped this straight line track, and the cone now almost looks like a straight line track at times. It's really phenomenal. So it'd be great to have the intensities catch up to that.
So how many of you are familiar with the Weather Act? Signed into law in the last year. Oh, you should look it up. It's authorization. It's not appropriation. But in there is recommendation to increase funding for hurricane research. Hurricane Forecast Improvement Project, for example. So that scientific challenge is far from over. And I do believe there will be a continued investment in it.
Thank you.
Hi, Craig Setzer from Miami. You mentioned it, I saw it in the slide, but can you expand a little bit on as Howard would say, HRRR and tsunamis?
Tsunamis? So in what context? Because
well, you didn't talk about it, but you saw it in the slide.
I had it on a slide. Yes. Oh, the reason I had it on a slide is that we have an operational tsunami model that we run at NCEP. It's based out of PMEL and the tsunami warning centers. In some other presentations, I have slides of that, and I could show you one. Yeah. I'll be here all day today and through tomorrow morning.
Anybody else have any other questions?
Kent Earhart from St. Louis, KMOV in St. Louis. I would to piggyback to the 500, 1,000, 200 year flooding issues. I think that there's a public conception, if you will, that well, the problem I think lies in the fact that we're changing the floodplain along, especially like the Mississippi River. We're seeing flooding in areas that wouldn't have been generated by, say, 10 inches of rain 100 years ago that are flooding, that are seeing massive flooding now. And as long as these levee changes continue along the floodplains, the flooding issue is going to get worse based on even less rain, let's say, but climate change clearly is going to be causing more intensive rain episodes. And I think that multiplies the issue, it compounds the issue.
No, that's very
There's a difference between a 100-year rain and a 100-year flood.
Yeah, that's right. That's a very good point.
And also the amount of urbanization that's taking place. That's part of it as well. Okay, Bill, thank you so much for really giving us great insight, and we really appreciate it. Let's give Bill another round of applause. Thank you very much.